So hello guys, this video will be about Lineweaver bark plot or double reciprocal plot. So this video will be the continuation of our enzyme kinetics. So in previous videos we have derived the Michaelis-Menten equation. We have talked about Km in details. We have talked about Vmax in details. So now Lineweaver bark plot is a graphical representation of Lineweaver-Burk equation. Now what is that? It is a new equation of enzyme kinetics or it something else? So this equation was described by Hans Lineweaver and Dean Burk in 1934. Okay, and Lineweaver and Burk trying to create a modified version of Michaelis-Menten equation so that they can provide a graphical representation of Michaelis-Menten equation. Okay, now I think you may know that for getting a straight line in the graph we should need a equation of y is equal to mx plus c, right, where your m is the slope and c is the intercept of y or intercept in the y-axis, right? So if you look at the Michaelis-Menten equation, you cannot represent this equation as y is equal to mx plus c. But if you take reciprocal of that equation, then you will get something that may be represented as y is equal to mx plus c. Okay, and this reciprocal version of Michaelis-Menten equation is our Lineweaver equation, okay, or Lineweaver-Burk equation. Okay, and with the help of this equation the graph or the plot that is created is called as Lineweaver-Burk plot or double reciprocal plot. Okay, so this is the idea of Lineweaver-Burk plot or double reciprocal plot. Okay, it is just a modification so that Michaelis-Menten equation can be explained graphically. Okay, and it was described by Hans Lineweaver and Dean Burk. And what we have done with the Michaelis-Menten equation to create Lineweaver-Burk equation, we have just taken the reciprocal in both the sides. Okay, and we get that. Now in the equation that I have discussed in the previous slide, here v is the reaction velocity and km is the Michaelis-Menten constant, and we all know that Vmax is the maximum reaction velocity and substrate concentration. So this is the Lineweaver-Burk plot. Okay, here slope is km by Vmax. So please remember about what is the slope, what is the intercept of y, because you may get the value of slope, okay, and they will tell you that it is a Lineweaver-Burk plot, and then Vmax will be given to you and you have to calculate the value of km. Okay, so you can easily done this if you know that km by Vmax is your slope. Okay, similarly they can give you the value of y intercept, sorry it is not y intercept, this one, and they may ask about what will be Vmax. Okay, so please remember that this one is your slope, this one is the intercept of y, which is the inverse of Vmax. Okay, and intercept of x will be inverse of minus km. Okay, so now the Lineweaver-Burk plot is useful for rapidly identifying important terms such as Vmax, km, and that is obvious. We can calculate about the value of Vmax with the help of the intercept of y easily, and we can see that, right? Now for instance, the y-intercept of such a graph is equivalent to the inverse of the Vmax, and x-intercept of such a graph is equivalent to the minus 1 by km. Okay, now let's talk about the calculation of km. How we can calculate the value of km. Now in the Lineweaver-Burk plot equation, if we take 1 by v as 0, then the formula for Km will be minus 1 by Km will be is equal to 1 by substrate concentration. Okay, so when they will provide 1 by V will be is equal to 0, then you can calculate the value of Km with the help of this formula. Okay, now this double reciprocal plot helps us to graphically represent Michaelis-Menten equation. There is no doubt about this. But nowadays, for detailed analysis of enzyme kinetics, modern workers use non-linear regression or an alternative linear form of the Michaelis-Menten equation. That will going to be our topic of next class, that is the Eddy-Hopsey plot. Because double reciprocal plot distorts the error structure of the data, which is unreliable. Okay, so you can easily remember that double reciprocal plot is useful for graphical representation of the Michaelis-Menten equation. We can easily derive the value of Km and Vmax, but for more accurate calculation, modern workers nowadays provide Eddy-Hopsey plot. We will going to talk about Eddy-Hopsey plot in details in our next video. Okay, and that will going to be the last video for enzyme kinetics. Then we will going to take another video where we will going to solve some problems from enzyme kinetics. Okay, so I hope you enjoying these videos and also you can learn something from this. So thank you for listening to this class.